Hello everyone. So in this video, we are going to see some example of the recursion. Like we will be doing some coding problem. Okay. So the first coding problem that we are going to do is like we have to find the factorial of a number. Okay. So we would have been given a number and we have to find a factorial of a number. Okay. So let us see how the factorial is defined. So suppose if we have been given 5, then what will be the factorial? It will be multiple of all the numbers till 1 to 5. Like it will be 5 into 4 into 3 into 2 into 1. Okay. So like it will be sum of, like it will be the product of all numbers till it's become 1. Okay. So how the recursion could be used here? So suppose we are up to 5, we are at the 5 and we find the factorial up to the 5. Let us try to see how we can do. If we are finding factorial of 1, then how will find factorial of 2? We will simply do factorial of 1 into 2. Okay. If we have to find a factorial up to 3, then what we will do? We will do 3 into factorial up to 2. Okay. So what is the recursive case? We can write factorial of n is equal to factorial of n minus 1 into n. So this is the recursive case. Like this is a recursive equation. Factorial of n is equal to factorial of n minus 1 into n. Till now, we have seen like this. Like we are up to, we have to find the factorial of 5. Then how we will do? We will do factorial of 5 into factorial of 4. 5 into factorial of 4. We can get the factorial of 5. Okay. So this was about the how we can write the recursive equation. Okay. So now let us try to do the same with the code. Okay. So let us define a function factorial where we pass the number. Okay. So, and what we need to return? We need to return n into factorial of n minus 1. So like this is our recursive case. Okay. So if we do only up to here, then it will go into the infinite loop. Like our recursion that will be exceeded. Like we are not stopping our function anywhere. Like when we call now factorial of n into factorial of n minus 1. So our factorial of it will go to the n minus 1, then n minus 2, then n minus 3, and it will go on till like it will go infinitely and it will never stop if we didn't add the base condition. Okay. So if we add if n less than equal to 1, then we need to return 1. Like this is the condition where we need to stop our function. Okay. So now do one thing, take input. Okay. Now we will print the factorial of n. Now try to run. For the 2 it should be 2. For the 3 it should be 6. Okay. For the 4 it should be 24. For 5 it should be 120. Okay. So I think it will be clear. Now let us try to do like if we didn't do at the base case, what will happen? Okay. So we would simply each time print n. Okay. And we are doing n into factorial of n minus 1 and we are not adding any base case. Okay. Let us try to run for 6. It is going into infinite loop and it is not stopping. Okay. So this was about the factorial of a number. Okay. Now we will do one more problem. Like we have to find the sum of number till n. Okay. Like suppose we are given 5 or 7, then sum till 7, what will we do? We will add 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. So earlier we were doing factorial of any number is the product of that number into factorial of n, like the product into factorial of n minus 1. Okay. But here what we are doing, we are only replacing that cross sign, like the multiply sign with the plus, like it's the sum of previous n number, like previous of n number. Okay. So let us define a function sum where we will pass a number n. Okay. And what will we need to return? We need to return n plus sum of n minus 1. Okay. How it's working? If we do n plus sum of n minus 1, like we are up at 7, like we are up to at 7, then we will add 7 plus sum of n minus 1, like sum of 6. So how it will do? It will add 7, then it will add 6, then it will add 5, then it will add 4, then it will add 2, and so on. And it will not stop if we didn't add the base case. Like we need to add some case where our function need to stop. Okay. So if we add, if n less than equal to 0, then we need to return 0. So we are adding this base case. Or we can also add, if n less than equal to 1, then we need to return 1. Like where we need to stop. Like we need to go till 1 and stop after that. Okay. So this was about the sum using recursive. Okay. So if we are taking input as n is equal to input, after that we are printing sum of n. Okay. Now let us try to run. Let us try for the run for the 3. It should be 3 2 5 1 6. Now let us run for the 10. It should be like 55. Okay. So it's working fine. Okay. So that was all about this topic, or all about the recursion. We will come up with the interesting topic again. If you like this video, keep like, share, and subscribe. Till then, keep watching.